AOPS number 13.14. If A and B represent digits of the base 10 number 60A5B, which is a multiple of 72, what are A and B? So 72 is prime factorized into 2 to the power of 3 times 3 to the power of 2. Since 2 to the power of 3 is 8 and 3 to the power of 2 is 9, that means it's divisible by 8 and 9. So 100A plus 50 plus B is congruent to 0 in modulo 8 because the divisibility rule for 8 is the last 3 digits. So that means 4A plus 2 plus B is congruent to 0 in modulo 8, which means 2 plus B is a multiple of 4. So B is equal to 2 or B is equal to 2 or B is equal to 6. And then if it's divisible by 9, that means 6 plus 0 plus A plus 5 plus B, which is congruent to A plus B plus 11, is congruent to A plus B plus 2, is congruent to 0 in modulo 9 because the sum of the digits has to be congruent to 9. So this thing, which is A plus B plus 2, is congruent to 0 in modulo 9, which means A plus B is equal to 7. Because since B is less or equal to 6, because it's in base 9, so it has to be less or equal to 6, so A plus B is less or equal to 15 as well. So if B, it can be, A and B can either be 5, 2, or 1, 6. Since B is equal to 2 and B is equal to 2 or 6, and A plus B is equal to 7, so it's either 5, 2, or 1, 6. So 4A plus 2 plus B is congruent to 0. So if it's 5, 2, this is satisfied, but if it's 1, 6, it's not. So that means the A and B are 5 and 2. AOPS number 13.16. A 9-digit number uses the digits 1 to 9 once each. What is the probability that the number is prime? So if the 9-digit number uses digits 1 to 9 once each, that means 1 plus 2 plus 3 all the way to 9, which is equal to 45. 45 is congruent to 0 in modulo 3, so there's no chance that it's prime because the divisibility rule for 3 is the sum of the digits is divisible by 3, and it is, so it has to be at least divisible by 3, so it can't be prime. So the probability is 0. AOPS number 13.18. How many 4-digit palindromes are multiples of 9? So 4-digit palindrome can be written as ABBA. So A plus B plus B plus A is congruent to 0 modulo 9, since if you want it to be a multiple of 9, the sum of its digits is a multiple of 9. So 2A plus 2B is congruent to 0 modulo 9. So A plus B is congruent to 0 modulo 9. So that means two numbers that sum up to something that is congruent to 9. So it can be A plus B, or A and B can be 1 and 8, 2 and 7, 3 and 6, 4 and 5, 5 and 4, 6 and 3, 7 plus 2, 8 plus 1, 8 and 1, 9 and 9, and 9 and 0. So that's 10 different numbers for A and B. So for each A and B, you can make an ABBA, which is a palindrome that's a multiple of 9, so there are 10.